In the epic saga of humanity, some chapters are so dark they almost became our final pages. There were times when our species teetered on the edge, moments hopeless enough that all living humans could have fit inside a single stadium. It sounds unbelievable now. We are more than 8 billion people strong across every continent, but if you look closer, not at bones, but at our genes, the record is chilling. Our species nearly vanished not once, but twice. DNA carries the memory of survival. Hidden signals in our genomes reveal two catastrophic bottlenecks when the global human population crashed to just a few thousand. Yet somehow, we endured. And these ancient crises didn't just test our existence, they shaped it. So what exactly happened in those dark ages? How close did we truly come to extinction? And crucially, could it happen again? To begin, you have to understand what a population bottleneck is. It's evolution's most ruthless test. When population numbers plummet, genetic diversity collapses too. The survivors, if any remain, rebuild from a dangerously narrow gene pool. Why does that matter? Because diversity is survival's toolkit. It fuels adaptation when life turns harsh, new pathogens, climate extremes, famine. Without it, a species is brittle. One disease or one long winter could wipe it out. That's why conservationists watch for bottlenecks in endangered animals today, like cheetahs, whose dangerously low variation puts them at perpetual risk. For a pathogen to strike and end them is no fantasy. Now imagine that exact ordeal, but for humanity, and not one, but 2 times in our deep past. Genetic studies show that between roughly 930,000 and 813,000 years ago, our human lineage suffered a catastrophic bottleneck. According to a genomic reconstruction using DNA from over 3,000 living people, the global breeding population may have dwindled to just 280 individuals, a drop of nearly 99%. That number isn't a typo. If a modern disaster left only 1,200 people alive, that wouldn't be a city. It'd be a tiny extended family. Yet for about 117,000 years, numbers stayed that low, barely clinging above extinction. How do scientists know this? They didn't find bones. Those are rare for that period. Instead, they traced patterns of genetic variation across present-day genomes. Certain variants act like tree rings in our DNA, showing how populations grew or shrank. With tools like FitCoal, researchers can read those rings to reconstruct ancient demography, and the results matched fossil gaps. Between roughly 950,000 and 650,000 years ago, there's almost no human fossil record. It wasn't that we haven't found bones, it is that there were almost no humans at all. What caused it? Likely climate collapse tied to the early mid-Pleistocene transition. Glaciers deepened, temperatures plunged, oceans cooled, droughts struck, ecosystems crumbled. One suspect is the Atlantic Meridional Overturning Circulation, a massive ocean current system that stabilizes climate. When it faltered in that era, catastrophe followed. Early humans, still weak with no control of fire or tools, were pushed to the brink in a cold, barren world. That ancient crash didn't just shrink our numbers, it may have reshaped our identity. During that same window, a chromosome fusion event occurred. Humans have 46 chromosomes, great apes have 48, thanks to human chromosome 2 being a fusion of 2 ancestral ones. That fusion likely happened either during or just after the bottleneck, and some scientists suggest it may have contributed to speciation, helping give rise to the modern human lineage itself. A key finding tracked via GLASP highlights how this bottleneck entailed losing about 98.7% of the breeding population and lasted 117,000 years, reinforcing how long and deep that genetic collapse was. This was not a brief dip. It was a sustained demographic crisis. That first ancient bottleneck wasn't just numbers, it was a genetic reset. Survivors carried a limited gene pool, but also mutations and structural changes that defined our species. We may owe our lineage, our speciation, to surviving that brutal phase. Fast forward hundreds of thousands of years, and a new human species begins to emerge, Homo sapiens, our direct ancestors. They appeared in Africa around 300,000 years ago, and over time they began to spread. They explored. They crossed rivers and deserts, and eventually they began to leave the continent that gave them life. This great migration was a turning point, and it nearly ended in disaster. For a long time, scientists believed a single catastrophe might explain the second major human bottleneck, the Toba supervolcano, which erupted in Sumatra around 74,000 years ago. It was massive, 10,000 times more powerful than Mount St. Helens. Ash clouds spread across the globe. A volcanic winter could have devastated ecosystems. This became known as the Toba catastrophe hypothesis, the idea that the eruption caused a sudden, drastic reduction in the human population. But recent studies challenge that narrative. Genetic data doesn't show the kind of sharp, sudden global loss of diversity we'd expect if Toba had wiped out most humans. And in key areas like East Africa, where early humans were thriving, there's little evidence of the kind of prolonged collapse Toba would have caused. So if not Toba, then what? What really caused the second bottleneck? The answer seems to lie not in one event, but in how Homo sapiens left Africa. Starting roughly 100,000 years ago, small groups began migrating out of the continent. But this wasn't a single wave. It was more like a trickle. Some groups didn't survive. Others returned. But eventually, a few small bands made it. And those tiny groups would become the founding population of every non-African human alive today. Think about that for a second. All the genetic diversity you see across Europe, Asia, Oceania, and the Americas, it comes from a shockingly small pool of ancient migrants. How small? One 2015 study looked at maternal and paternal lineages in 51 global populations. It estimated that the founding groups may have included as few as 25 women and 15 men. That's 40 people. 40 individuals who carried forward every language, every tradition, every future culture outside Africa. It's a terrifyingly narrow escape. These early explorers faced environments they'd never seen before. Colder climates, bigger predators, new diseases, and they had very limited genetic tools to adapt. A single virus could have erased a whole migrating lineage, and some likely were erased. We just don't know about them because their descendants didn't make it. But a few survived, not by force, not by luck alone, but through persistence, through adaptability, and perhaps through connection with other bands of humans they met along the way. Even today, the genetic record still shows the echo of this bottleneck. That's why genetic diversity is greatest in Africa, where our species has had the longest and deepest roots, and lower in populations that migrated outward. The further from Africa you go, the narrower the gene pool becomes. That's not a weakness necessarily, but it's a reminder. Our ancestors stepped into the unknown carrying only what little they had. Now you might wonder, if these groups were so small, why did we survive and not the Neanderthals? After all, Neanderthals were no slouches. They dominated Europe and parts of Asia for hundreds of thousands of years. They hunted, made tools, adapted to the Ice Age, and we know we interbred with them. Modern humans today still carry Neanderthal DNA, but the Neanderthals didn't make it. Why? Genetic studies point to the slow grind of demographic decline. Unlike us, Neanderthals lived in small, isolated groups, and over time, this led to inbreeding and genetic decay. A 2019 study of 13 Neanderthal skeletons showed rare congenital disorders, signs of developmental stress and inbreeding. Another analysis of their inner ear anatomy revealed steep drops in genetic diversity in their later history. All signs of a species trapped in a slow, irreversible spiral. They didn't disappear in a single moment. They faded, generation by generation, as their genetic resilience wore thin. They couldn't bounce back. They didn't have enough numbers or enough connection. And here's where Homo sapiens had the advantage. Africa, the motherland. While some small groups were migrating and risking extinction in Eurasia, a large, genetically diverse population remained behind in Africa. They weren't just reproducing, they were innovating, experimenting, making better tools, building social networks. So when those outlier populations ran into trouble, there was still a source, a biological backup, that could replenish the gene pool and keep the lineage going. Neanderthals didn't have that. They were stuck. They were alone. And in the end, that isolation was fatal. So when we talk about why humans survived while others faded away, it's not just about strength or fire or intellect. It's about numbers. It's about diversity. And most of all, it's about connection. The second great bottleneck wasn't a volcanic apocalypse. It was a long, drawn-out gamble made by a few brave souls who walked out of Africa and seeded the future. It was a slow-motion crisis of risk and resilience, and somehow we beat the odds again. Every single one of us alive today is descended from those tiny groups, those few dozen men and women who stepped into the unknown. Whether your roots are in Europe, Asia, the Pacific Islands, or the Americas, your ancestors were part of that fragile chain. That's why non-African populations have lower genetic diversity. It is a signature of survival through constraint, a memory of a time when survival wasn't a T guaranteed. And that genetic tightrope walk didn't just shape our numbers, it shaped our biology. After all, bottlenecks aren't just population events, they're evolutionary filters. When only a handful survive, they pass on not just their genes, but also their quirks, strengths, and vulnerabilities. In other species, this process has driven rapid change. It's likely the same happened with us. Which brings us back to the Neanderthals. Their bottleneck wasn't just about numbers, it was about fragmentation. They were spread thin, isolated in small pockets across Ice Age Europe and Western Asia. No big cities, no robust networks, just small groups, separated by mountains, glaciers, and time. That isolation hurt them. When scientists studied Neanderthal DNA, they found it riddled with signs of inbreeding, accumulated mutations, reduced fertility, and health issues. One striking example? Many Neanderthal remains show physical abnormalities. A 2019 study of multiple Neanderthal skeletons found deformities that pointed to congenital disorders, likely the result of inbreeding in a shrinking gene pool. There is even evidence that they started losing basic diversity in brain and inner ear structures, traits that are important for balance, coordination, and even communication. These losses made it harder for Neanderthals to adapt to changing environments. In the harsh game of survival, even small disadvantages add up. And yet, they held on for thousands of years. They were clever. They used tools. They hunted mammoths and lived in caves. But when Homo sapiens arrived in Europe, everything changed. We brought competition, yes, but also new diseases, new technologies, and perhaps most critically, a genetic flood. There was interbreeding. We know that now. Most people outside Africa still carry between 1% and 2% Neanderthal DNA. That means some interspecies contact wasn't as just possible. It happened often enough to leave a permanent mark on our genome. But it wasn't enough to save them. Neanderthals eventually disappeared. Why did we endure while they faded? Some scientists think the key wasn't just strength, but adaptability, and maybe even empathy. Humans are uniquely collaborative. We don't just survive, we share. Knowledge, tools, shelter, culture. These networks of support may have given us an edge that no individual strength could offer. More importantly, we weren't isolated. As Homo sapiens spread across the globe, we stayed connected, at least at some level. New ideas traveled, populations merged, diversity was preserved. Neanderthals, by contrast, were fragmented, alone, vulnerable. That's the real lesson of these two ancient bottlenecks. Numbers matter, but connection matters more. Because a bottleneck isn't just a dip in headcount, it's a collapse in potential. Without diversity, a species can't evolve. It can't adapt to new threats. It becomes fragile, like a vase held together with invisible cracks. And this brings us to a sobering question. Could it happen again? Most people assume that since we're 8 billion strong, we're safe. But remember, population size is only half the story. What matters just as much is genetic resilience. If a future disaster, be it a nuclear war, a global pandemic, or a rapid climate collapse, wiped out most of our population and left behind only small, isolated groups, we could face the same narrow genetic funnel. Even today, we're seeing signs of concern. Many of the world's communities are becoming more genetically similar due to global travel and intermarriage, but at the same time, we're also seeing loss of traditional diversity as indigenous groups vanish and local lineages disappear. That's genetic resilience, quietly fading. And in some ways, we're creating new forms of bottlenecks through choices, reliance on industrial agriculture, loss of biodiversity, dependence on centralized technologies. We may be setting ourselves up for fragility in places we haven't even considered yet. So the ancient bottlenecks in our history? They're not just stories about the past. They're warnings. Our survival isn't guaranteed by our numbers or our cities or our technology. It depends on our ability to stay diverse, to stay connected, and to avoid becoming too fragile in our success. Because what saved our ancestors wasn't just luck. It was adaptability, diversity, and above all, each other. If you're still watching, that means something about this story resonated. And maybe it's because deep down, we all sense how fragile survival can be. Our species, so powerful now, so dominant, was once no more secure than a matchstick in a storm. And in some ways, we still are. We like to believe in progress, that we've outrun extinction, that modern medicine, global trade, and satellites in the sky have made us immune to the threats that once stalked our ancestors. But history tells a different story. Extinction doesn't need to be loud. It doesn't need an asteroid. It can come slowly, quietly, like it did for the Neanderthals, like it nearly did for us. And the threats we face today? They're not ancient predators or volcanic winters. They're of our own making. Climate change is accelerating faster than at any point in the last 65 million years. Oceans are warming, ice caps are melting. Extreme weather is becoming the new normal. We're witnessing not just environmental collapse, but ecological destabilization on a global scale. That same Atlantic circulation current that may have contributed to the first great bottleneck? Scientists now warn it's weakening again. If it collapses, it could trigger massive shifts in weather patterns, agriculture, and global habitability. Add to that the looming threat of nuclear weapons. Still, in 2025, thousands remain on high alert around the world. The wrong conflict, the wrong miscommunication, and we could see cascading effects, not just geopolitical, but biological and environmental as well. Then there's artificial intelligence, automation, and economic fragility. Entire industries are shifting. Entire job markets are disappearing. And while some adapt, others are left behind. Economic collapse doesn't always look like chaos. Sometimes, it just looks like millions of people without purpose, without stability, without direction. Even pandemics, something we thought we understood, proved how vulnerable we remain. COVID-19 showed how quickly the global system can shatter, and that was just a preview. Scientists warn that the next pandemic may come from deeper in the permafrost, from antibiotic-resistant strains, or even from synthetic biology. And through all of this, the question that lingers is, are we resilient? Not just in terms of infrastructure, but in our DNA, our diversity, our capacity to adapt. Because here's the thing about bottlenecks, they don't announce themselves. You don't always see them coming. You survive them or you don't. And if you're lucky enough to make it through, you carry the memory forward, not in stories, but in your blood. That's what makes the ancient story so haunting. We don't just know it from fossils. We know it because every one of us is a living record of it. Our genes tell the tale. The fusion of chromosomes, the missing branches of diversity, The clues that say, once upon a time, there were only a few of us left. And still, we made it. That survival didn't happen because of a hero or a miracle. It happened because of many small decisions made by ordinary people over generations. To move, to stay, to help each other, to take a risk, to try again. That's what we carry. Not just the science, but the spirit. The resilience written not in code, but in choice. And in a world that feels uncertain, that legacy matters more than ever. Because just as bottlenecks can erase, they can also create. They forge new paths, they harden what survives, and they make space for something new to emerge, something stronger, more connected, more aware. That might be the best part of our story. Not just that we survived, but that we changed. That we became better at surviving together. Because let's be real, no one makes it through a bottleneck alone. We've seen that in every chapter of our history. The spread of agriculture, the rise of civilizations, the sharing of language, trade, and culture. Every step forward happened not because of isolation, but because of connection. The ability to collaborate, to innovate, to learn from each other. That's what pulled us out of darkness. Again and again. And maybe that's our most important evolutionary trait. Not our brains, not our tools, not even fire, but our ability to reach across the unknown and say, you, too. Let's survive this. Let's build something. It's easy to forget that in a world full of screens and silos. But the truth is, we still depend on each other, still depend on diversity, on difference, on the richness that comes from mixing perspectives, cultures, and DNA. Because a future without that connection, that's how bottlenecks begin. Quietly, incrementally, and often too late. So maybe the next time you hear about genetic diversity, endangered species, or climate feedback loops, you won't just hear science. You'll hear memory. You'll hear the echo of a story that began almost 1,000,000 years ago, and maybe you'll remember that we've been here before, and we made it. And here we are, on the other side of all those ancient trials, a species of billions walking the earth with smartphones, space programs, and AI. But at our core, we were still the descendants of survivors, those 1,180 souls who endured an ice age nearly 1,000,000 years ago, and the brave few dozen who stepped out of Africa into the vast unknown. Their legacy lives in our blood, in our cultures, in our curiosity. Because survival wasn't just about outlasting the cold. It was about something deeper, endurance through connection, through building, sharing, adapting. Not in isolation, but in tribes, in communities, in families that stretched across space and time. That's why we didn't just survive, we flourished. And that ability to connect, to bridge gaps, to pass knowledge down like fire in the dark, that might just be the most powerful tool we ever evolved. Just look at our closest cousins, the Denisovans, the Neanderthals, Homo erectus, all incredible in their own ways, all now gone. Some interbred with us, some left tools, bones, and echoes, but none are here today. So why are we? Scientists point to a few clues. A larger, genetically rich homeland in Africa, our backup drive, so to speak. An edge in cultural flexibility, symbols, language, ritual, art, a greater willingness to move, adapt, mix, and even help each other. These things may have made the difference. Because in small isolated groups, genetic collapse is inevitable. Traits don't get shuffled, defenses don't evolve. Inbreeding creeps in, and when a new threat comes, whether it's a drought, a virus, or a predator, there's nothing left to draw from. But in a connected species, the opposite happens. Diversity circulates, ideas spread, mutations with advantages travel across regions. The entire species becomes more robust, more flexible, more able to face the next unknown. That's the secret. That's why we're still here. So what do we do with that knowledge? We remember. We remember that no species, not even us, is immune to extinction. That even in the age of satellites and supercomputers, resilience still depends on diversity, on connection, on empathy, and we act. We protect the ecosystems that protect us. We defend endangered languages, cultures, and people. We build systems that embrace complexity rather than flatten it. We resist the urge to isolate and choose instead to share. Because we're not just inheritors of survival, we're stewards of it. And make no mistake, the next bottleneck, if it comes, won't look like the last. It might not be triggered by ice or fire. It might be digital, economic, ecological. But the principles remain the same. If we're fragmented, brittle, and blind to our interdependence, we risk following the same path as those who came before us. But if we stay open, connected, and aware of our shared fragility, we might just beat the odds again. The shadows of our past bottlenecks live inside us. They're in our DNA, in the gaps in our genomes, in the strength of our lungs, adapted to distant mountains, in the shape of our ideas, molded by generations of challenge. But so too does our hope, our persistence, our genius for adaptation, and that's why these stories matter, not because they're ancient, but because they're ours. So the next time you hear about a threatened species, or a forgotten language, or a changing climate, don't think of it as something distant. Think of it as part of your story, because it is. We are the descendants of those who refuse to let the human spark go out. And if you've made it this far into the video, congratulations. You're part of that legacy. Thanks for sticking with me through one of the most dramatic and humbling stories in our species, history. If you want to explore more hidden chapters from the human past, hit that like button, subscribe, and let's keep uncovering them, one story at a time. See you in the next one.